This is the Blueprint Podcast, bringing you the latest in cyber defense and security operations from top blue team leaders. Blueprint is brought to you by the SANS Institute and is hosted by SANS Senior Instructor John Hubbard. And now, here's your host, John Hubbard.
So I'm going to guess you've been thinking a lot recently about the security of our industrial control systems and critical infrastructure. I know I have. And so for this episode of Blueprint, we've got an expert in ICS security, Dean Parsons, who we're going to talk to about what ICS and control systems are, the different types of threats and attacks you should consider when defending these systems, and how to monitor and make sure your ICS equipment stays secure. All that and more on this episode of Blueprint. Hello, everyone, and welcome to the Blueprint Podcast. Today on the show, we have Dean Parsons, who is a SANS instructor from our ICS curriculum and a OT and ICS cybersecurity expert. Welcome to the podcast, Dean.
Hey, thanks so much, John. Totally appreciate you having me. Appreciate it.
So before we get started here, can we get a quick rundown from you on kind of your background and your history and your expertise and what kind of stuff you're working on now, so everyone's kind of aware of where you stand in your kind of knowledge area here?
Yeah, absolutely. So like in 30 seconds or less, way back in high school, I started hacking Linux. That was my interest really back then. So writing code, recompiling my own versions of Linux and whatnot is really my interest started there. And then started obviously creating code, exploit code, and understanding what security meant. So early on in my career, I wasn't in ICS. So for after my degree, I did 10 years in IT. So building teams, so looking at packets and presenting to boards of directors and people like that as well. But for the last 10 years, I've been really focusing on industrial control systems. So early on, telecommunications, IT, and then the last 10 years has really been on critical infrastructure, specifically in the electric sector. So generation of power, transmission, distribution, but also recently in oil and gas as well. But in addition to that, any number of assessments in those areas, critical manufacturing as well, and of course, chemical plants and other types of plants as well. So.
Very cool. Yeah, this is a topic that I'm really interested to discuss here because it's not something we've covered before. I know a lot of times, students and someone earlier on Twitter today had just mentioned like, hey, I want to know, about this kind of space. So I would love to, throughout this conversation, kind of get through how do we think about defending these kind of systems as opposed to like general IT, and like how do we work with a SOC, and how do we kind of think about the different types of threats that we might face for OT and ICS versus traditional IT stuff. So hopefully that's a place we can go with that. Before we get started, let's do some kind of definitions here, because I know not everyone's specifically familiar with, OT versus IT and all of that. So
right.
Could we start out with kind of what those terms mean and what types of systems fall under those different umbrellas?
Absolutely. It's a great question. So I'll start off by saying a control system, a non-industrial control system, most organizations or people have in their homes. So a control system at a simplest kind of perspective can be looked upon as like a thermostat in your home that controls the heating or cooling in your home. So that control system really has sensors that senses the atmosphere, the area in your home, senses the temperature. So that's the basic crux of a control system. And of course, those thermostats have a logic in them that says, well, the temperature you wish is not where it should be, so I'll increase the heat, or I'll lower the heat or cool the environment down. So that's generally a control system that senses the real world and makes changes in the real world. Now, an industrial version of that, of course, is much more complex, much more expensive, but also impacts the people and an environment on a larger scale. So think a power generation station, transmission, distribution system, or grid that powers a region, city, town, or country. Now that's an industrial control system with many, many moving parts. But again, the simple aspect of it is that it still senses the real world and makes changes in the real world. So an electric system is one example, but there's several others. So for example, a wastewater management facility that takes water in from a region that cleanses that water, puts it back into a region is another example. And these systems sometimes are said to be IT, but they're certainly not. The good news is, from a defense perspective or security perspective, is we can leverage some of the things we've been doing for decades in IT security and adapt and use some of that in ICS and larger critical infrastructure environments. But there's definitely a nuanced discussion we have to have with a different perspective on things like hunting and general intrusion detection and security. But that's generally a control system and, examples of industrial control systems. And that doesn't stop there. Wastewater management, as we talked about, but there's also chemical manufacturing, food and beverage manufacturing. I would say the things that we as a societal structure or civilization relies on a daily basis. So every time I'm asked the question, well, what is ICS? What is OT? And I ask the person, well, what did you do before asking me that question today? And it's usually, well, I commuted to work, but before I got to the office, I pumped gas into my car. And so, maybe then they go and take money out of the bank. And all of these things kind of add up to they probably interacted with, touched, or relied on 5 or 6 different critical infrastructure systems before they even got to work. And, the gas pipeline event that we seen last year is one of those examples where we rely on refined fuels to be available for transportation. So obviously oil and gas is a major sector in the critical infrastructure or ICS OT space as well.
Yeah. So tools that are, I guess, controlling something in reality, tell me if I'm correct here, but also maybe connected to the internet and interfacing with our traditional IT networks or something like that. Is that what we would call, like, say my smart thermostat, right? I have an Ecobee, it connects to the internet, I could run it as an HTTP web server or something, right. I'm sure that's probably totally super safe and also controls the heat in my house, right? Right. Does that fall under the OT umbrella, or is that, it's clearly a control system, as you said, right? Does the connection and interfacing with traditional, internet and other stuff, does that make it one camp or the other then?
Yeah, so that's a great question, and there's several, acronyms for this. It's IoT or OT or IIoT. Generally, if it's a control system that interacts and senses and changes the real world, it's a control system to some degree. But yes, you're right. Now, the point you raised about being connected to the internet, we've come a long way in the last 20 years in industrial control systems where we were air-gapped. Right? Today, that's not the case. And for various reasons, in general, control systems have adapted and used traditional IT systems, traditional IP protocols, TCP/IP stacks where we haven't before. But we have converged, if you will, and been using those technologies for 20 years. So the good news is we're leveraging all the things that comes with that adoption using IoT and that type of technology. But we've also brought along the related risks to that as well. But you did mention the point, John, about being connected to the internet. With the connectivity we have, even inside control systems, yes, that air gap has gone away, and we are much more connected inside our organizations to maybe some IT networks. But yes, we have controls that are available for remote access from the internet into some ICS facilities as well, with good, hopefully, security controls, mind you, as well. So one example of, you mentioned your thermostats connected to the internet. The obvious question is, are there attackers out there that can maybe probe for that kind of connectivity? And absolutely there is. And that's why that industrial control systems should be secured in many, many different ways. And we can, and we've achieved that generally, but some organizations are a little bit behind the curve on that. So there is risk as we've connected more in the last 20 years. There's risk with us using traditional IT technologies the last 20 years. But I would say that ICS defense, even in the case of connectivity, is definitely defendable and it's doable.
Yeah. So let's say we have kind of a brand new company. They need to use this kind of technology and they need to have some kind of connectivity to it. What is the basic approach that someone needs to take to deploy this kind of technology, but also segment it or defend, well, kind of all that stuff, right? Is there the first things you asked if someone were to hire you as a consultant and say, help me do this right? Where do you start with that?
Yeah. So we don't have enough time, but I'll really try to condense it as much as I can. Sure. So in general, when I do assessments in these facilities, it's really the first thing I do is I really understand how the networks of the control system is connected. And when I say connected, it's connected to IT, or connected to the internet, or connected between other control system zones. So I really start off with a technical look at the network, the environments, and I try to align what they have in place to the Purdue model, which is generally a zoning kind of framework which we follow and add security into these zones. So really, it's all about starting with network architecture, segmentation between the industrial controls and IT, and segmentation between the industrial controls and the internet as well. And yes, there may be some connectivity between them, but again, you can use that connectivity in a way that is defendable or restricted to only what's needed. We still see adversaries pivot from the internet or attempt to pivot into the ICS from the internet, but also we constantly see adversaries possibly getting access to an IT network and also try to pivot from IT into the industrial control as well. Now, I don't want to get too technical unless you do, but I do want to raise the point that when I do assessments, we talk about architecture, there's usually one or two systems that usually require connectivity from IT into ICS, and that's called a data historian. And this generally allows the organization, the business, to understand what the control system is doing and understand if there's efficiencies to be made there. So this data historian has a trusted access, if you will, between IT and ICS, possibly in a demilitarized zone in the ICS environment. And my point in saying that is that architecture is a great place to start because it's affordable to do defense there first. And anything you build on top of ICS defense, of course, with a strong architectural foundation is going to be so much more return of investment. It's so much more valuable as you build on that architecture. But I do want to say for those listeners out there that we have, like, having the data historian system monitored accurately and having controls around it to make sure that only the folks and connections that are needed to get access is in place, that is critical because, again, as a tactic, technique, and procedure or attack, methodology we see is coming from IT into the ICS on a regular basis. So we'd call that a hotspot, but again, it's totally defendable, right? So I'd start there.
Yeah. So, I mean, to me, it sounds like the approach here is the same thing a lot of us have been thinking about for general IT for a long time. It's like, if the connection doesn't need to be there, don't let it be there. And then when it is there, make sure it's restricted as much as possible and you're monitoring everything. Is that fair to say?
Absolutely. At that level in the industrial control environment, at the high level of the network, that is absolutely the approach. And so architecture is, again, I'll say it's affordable. I see organizations out there when I do assessments and they say, come in and help us justify a budget for X, Y, Z. I'll absolutely do whatever I can and abide by, the restrictions that I have and the general best practices and knowledge that I have and experience. But it comes down to, sometimes it's John, the organization wants to spend $200,000 or $300,000, $400,000, $500,000 or more on a technology that if they do that, it's going to be kind of shaky, right? It's like building a wall or walls on top of a house with a shaky foundation. So many times I suggest, like, that's a great idea, but if we just push that project you have and that budget off maybe 6 months or 8 months or a year and really focus on the network architecture first, aligning with Purdue, then your house that you're going to build in a year from now is going to be so much more solid. So, but yeah, it's generally starting with that architecture, least privilege, that kind of stuff. But when we talk about least privilege in ICS, it's not necessarily just users because we have far few users in ICS, which changes the risk profile significantly in ICS. I'm not saying there's no risk, but it's not a user-initiated risk. We don't have to worry so much about email systems. But having said that, email still is the number one way to get into any organization, IT or ICS. And we still see adversaries break into IT and somehow craft an attack for ICS, either digitally coming from IT into ICS or some other way. So there is, some things to be considered there.
Yeah, I mean, that sounds like a very familiar struggle, even like ignoring the whole IT and OCS thing. It's just like, oh, I heard about a blinky box. We should buy that thing, right? Because that's going to solve the problem.
Right, yeah, exactly.
Sorry, I didn't almost mean to cause a spit take there. That's hilarious.
Yes.
Thing we constantly hear about is like, oh, XDR, UBA, right? Like, yeah, but like, can you control what you plug into the network first before we get into that kind of, and everyone's always obviously distracted by that stuff. So it sounds like a very similar issue. I want to ask the converse question of this. What's the wrong way to do it? And when you see it fail, what are the failures and how do those failures typically manifest?
Yes, that's a great question. And I'm going to look at it from a management perspective first. So I'm a certified instructor for 515 and 418. And so 515 talks about industrial control system, visibility on control systems, active response, incident response that prioritizes safety. And in ICS 418, I really focus on the leadership. So training managers or those responsible for ICS risk management. So to answer your question, I'm going to start at the risk level, the higher level. So where do I see industrial control systems cybersecurity fail? And I see it fail when there is a culture that does not prioritize safety above security or safety above anything else. The biggest thing, or one of the 6 big things between IT and ICS, one of them is safety. And so what I try to do is I try to make sure that the culture in security is really adapted to the physical safety culture in plants. And when that happens, everything shifts for a positive way. So to reverse that, the failure is really security teams coming in or security managers coming in and be like, I'm here for security. I'm going to secure your plant, secure your facility. And it's like guns ablazing inside of an ICS environment doesn't work, because they typically do take IT security controls, methodologies, processes, and for lack of better words, John, they copy and paste them into the ICS. And the problem is, and I've seen this fail, where teams go in guns ablazing and they paste in the IT security stuff. Something happens, i.e. a false positive on a network that's a control network, and something happens. So there's a safety problem, or there is something that happens as a result of a security technology. And then that team is like, you know what? You're not allowed back in here. So I've seen teams get kicked out of plants and they don't come back. And the problem with that is that the risk is not addressed. So the approach to doing ICS security is really hinging on the cultural aspect and the managerial kind of security is here to support the safety and reliability of operations. So I see it fail when it's the opposite of that. From a technical perspective, because we talked about the management side, I think from a technical perspective, if IT security folks who are uneducated in ICS specific security technologies, the protocols, which you never will see on an IT environment, if those folks are tasked with the responsibility of securing the ICS, it's really prudent to make sure those individuals really have an understanding of the engineering environment, the ICS specific control systems, the specific protocols that you're going to be dealing with and seeing. Also, the different attack methodologies that we see in ICS. There's very different profile of risk, very different approach for security. So I see it fail, unfortunately, when those from IT jump into ICS or are told to do ICS security and don't have that knowledge and background of what they're looking for, how an adversary actually operates in ICS. So those are the 2 main things from a management perspective and a technical perspective.
We'll be back after a quick break.
If you're enjoying this episode, then you're undoubtedly interested in building the strongest security operations team that you can. For those who want to go even deeper, did you know that SANS has not 1, but 2 courses that cover security operations centers as well? For the leaders, managers, and directors out there, my co-author Mark Orlando and I offer 551, Building and Leading Security Operations Centers. This course covers building your team, your physical and virtual workspace, getting the right data into your tools, and then focusing on security priorities through everyday execution of important security tasks and building the best SOC team possible. For the technical practitioners out there, my course Sec 450, Blue Team Fundamentals, Security Operations and Analysis is designed to cover everything you need to jump in being the best SOC analyst that you can be. We cover important data types, SOC tools, security logs, malware, analysis technique, automation, and much, much more. In addition, if you want to prove you can deliver the best on any security team, both courses have an accompanying certification available from GIAC. That's the GSOM for 551 and the GSOC for 450. Check out both courses and free demos available on the SANS website. You can get registered today for an in-person course at one of our many events, or go to On Demand and take either class anywhere at your own pace. Thanks for listening. Yeah, so that's an interesting way of approaching that. I like that. Let's tear into the first one for a second. What is it that causes, in your opinion? I mean, I know this is a very difficult question to answer in general, but the failure of security being a priority. Like, When that's happening, is it because, oh, we just need to get stuff done? Is it because they don't know how? Is it because in the past that's just how that's happened? Like, if that's the case, why is that typically the case in your experience? And how do we start to shift that in the right direction?
Yeah, so another great question. So I really see the crux of that problem growing, and how it becomes to be is that there's a lack, not everywhere, but there's a lack of understanding and misconceptions about the differences between IT and ICS. And so a lot of boards who unfortunately may be unaware of the different risk surfaces and impacts in ICS say, well, we have an IT security team. Let's just make sure they do the plants too. And they consider the control systems IT security, and they're just not. So I see it fail when those tasked with IT are told to do ICS security, but don't have that background, as I mentioned, and executive are perhaps not understanding the differences there. And so how to win at that is really know the differences. It's not just the technologies that are different. There's control systems that you will never see in an IT environment that act very differently. Sometimes you can't patch, sometimes you can. These are solid state engineering devices that are not running Windows, as an example. So it's a very different kind of infrastructure that should be managed and treated as an industrial control environment. And a great example of this is a Windows system traditionally in IT is patched every 30 days. We've been doing that in IT for decades, and it works very well, like clockwork. But patching in ICS is not the same thing. And even we do use some Windows devices in ICS, but those devices, I would absolutely argue that they're OT devices running engineering software that allows an engineering operator to click on a software that's engineering and control something in the field, directly influencing the real world and safety. So back to your original question, I think that there's the misconception there of how different they are. They're very different. But what I am seeing on a positive side is when I do assessments, a lot of the boards now this year, last year, compared to 2, 3, 4 years ago, are starting to ask the right questions. And now they're representing security in the ICS space as a separate, risk on the risk register for the organization. And they're really involving safety because now they're educating themselves enough to know that a security event in ICS can absolutely have a real world safety impact to a person or a number of people, workers, and also the environment. And we've seen these things over the last 5, 6 years. Stuxnet was way back, and we've seen things here now in the last couple of years. Malware specifically designed to control engineering devices with the Trisis malware, right? So that can impact safety, and specifically that targeted a safety instrumented engineering system. So, and the only reason to create that kind of malware, in my professional opinion, to attack a safety system is really to kill people or destroy or possibly help destroy a physical component in a plant. So, yeah, a lot to consider.
Definitely a scary kind of malware for sure, considering what the intent seems to be in those things. One of the things you touched on is assessments and just kind of people having the right mindset about, not having the IT people do the work. Excuse me. For the leaders out there, is it possible to say, like, here's a way you can test the team and see if they have the right skills? Or like, what's the sniff test for saying, like, do we have the right people with the right knowledge here?
Yeah, so I think there's probably several. So I'll tell you a little bit of a story and kind of answer the question this way. So I've done a lot of hiring in the last, say, 5 to 6 years. I've been tasked to build ICS specific security teams, hunt teams for OT, and so on and so forth. And sometimes I hire amazing folks, and they stick around, and they're from IT, they're from engineering, they're from other kind of areas and fields as well. And what I find the most interesting is that when IT security folks come in for the interview and they do really well in the interview, and I ask some questions about engineering, and clearly they've done some reading and whatnot, but they don't have the practical knowledge yet. And that's not a stop the show kind of thing. It's bring them on board, get them trained specifically to what their tasks are going to be. But one of the sniff tests, I guess, is, so you're from IT security. What's the first thing you want to do in the ICS? And it's like, I want to encrypt everything, like encryption all over the network. And it's like, well, let's have a nuanced discussion there, right? Of course, encryption does help things. You have confidentiality, integrity, and availability. Confidentiality, obviously, what you're going to get primarily with encryption. And if you do that inside of a control system without thinking it through, it's, well, you're slowing the real-time systems down, the SCADA environment that has to sense things from the real world. But what do you actually buy inside the control network by doing encryption? Because in IT, when you do encryption, you're preventing other people or other systems to get access to confidential data. Inside the ICS, that data is control system traffic, and it needs to be protected, but not from users, because we don't really have users as such inside the ICS. So it's a very different kind of risk surface. So back to the sniff test, I'd ask, what's the first thing you would do inside of an ICS security zone? And if it's encryption, the first thing I do, and the first thing I do with anybody that I hire, is I get them physically to site. And it's really good, because they're like, yeah, we're going to site, it's awesome. And we gear up in physical protective equipment, right? We have hard hats, and there's like ear protection, eye protection, knee pads, like the whole thing. Before entering a site, you have to have your safety certification complete. So when you get IT security folks who are super passionate, and I love that passion, and that's what I look for, when you get them to the site, things change, because it's like you're not sitting in an office anymore, and they realize, if we copy paste our IT controls in here and I break something, that means that an arm that is a mechanical robot arm that's building a car could swing the other way and hit people, like these kind of real world scenarios. So I love seeing them get to site, learn what an ICS actually is by physically being there, hearing it, understanding it, seeing it. And then the discussion and the sniff test is like, you know what, probably shouldn't encrypt right away, or maybe not at all, or maybe in certain zones. For example, site-to-site encryption going out over leased lines, absolutely do encryption, right? So that's one sniff test. What's the first thing that they would do inside the ICS from a security perspective? I think beyond that, and I have been known to do this in interviews, is I print out 2 pages of a PCAP, or looking at the network. And so we say, you know, what do you see that's malicious in this PCAP? And I give it to them, and it's a Windows communication. So they're very familiar with Windows devices. In this case, it's an OT device. And they say, you know what, looks like command and control, looks like there's SMB or some Windows stuff happening, and it's really crazy and it looks evil. So possibly that's what you're looking for in this PCAP. And I say, you know what, absolutely, this is general IT stuff you're seeing. Absolutely, this is likely malicious. So that's great. And then when I give them the second PCAP to look at, and they go through and they're like, well, I don't see anything evil here at all. And really what I give them is control system specific traffic, and a human machine interface talking with a PLC in the field, engineering devices talking back and forth. And the IT security person will say, I see nothing wrong here. But if you give that same PCAP to an engineer, immediately, like within seconds, John, they're saying, you know what, I know this traffic, and it's extremely odd, because the frequency they're communicating is extremely high outside the engineering specifications. So that sniff test is really, do you understand industrial control systems and how they work? So I would really start there with the sniff tests. And I found that people that don't get that second sniff test, they're super eager to learn. And that's when you can mold those people to understand what ICS security is. So
if you've been with us through season 1 and 2, you've undoubtedly heard me talk about some of the courses that I've authored for SANS that are near and dear to my heart as a lifelong blue teamer. What you may not know is that every year and multiple times per year, these courses continue to get better. One of my favorite classes to teach is Sec 450 Blue Team Fundamentals, which is a technical class I designed for anyone working as a cybersecurity analyst for teams large or small. We continue to update the class and bring in new information on the newest threats, data, and protocols that any defender needs to be aware of. In the most recent course refresh that went live just about a month ago, I've continued to hone the content, diving further into cloud defense, automation examples, detection for modern attacks and attackers, including common things like ransomware and much more. And we've also brought increased focus on new and more difficult to monitor network protocols like HTTP2 and HTTP3, DNS over HTTPS, and TLS 1.3, things that every blue team needs to be familiar with or will need to be very soon. Every version of this class comes with continued focus and updates, and this class is huge. I don't know of any other security operations course out there that contains nearly 1,000 pages of slides and notes, 15 hands-on labs with a virtual machine to go with them, including another 400 pages of step-by-step exercises for those hands-on exercises, video walkthroughs of all of those exercises, MP3s, a course wiki, and a whole day CTF where you can apply the skills you've learned in class throughout the week. My goal with this class is to bring you the absolute most comprehensive security operations and analysis course possible, and I'm continuing to strive with every release to keep updating the course and deliver on that mission. The depth of content in this course is something that SANS is uniquely positioned to deliver, and I hope you'll check it out if you have a free moment. Go to sans.org/sec450 to check out the free course demo, which is a free full section of the course, and an in-depth syllabus to see if it's right for you. We have options to take it live in person, live online, or at your own pace with SANS On Demand. And unlike some other training courses, SANS and I are there to help you along the way with personalized help and explanations for any questions you may have. With the recent release of the GIAC GSOC certification, anyone that takes the class can now get the corresponding certificate that shows that you've put in the work and have what it takes to go head-to-head with modern attackers. I really think we put together something special here, and I hope you check it out. Thanks for listening, and now on with the show. Yeah, that's an interesting way of looking at it. And I want to get back to kind of both pieces of that, the training and how do we know what we're looking at and how do you gain that knowledge. But before we go there, the other piece, what would you do, right? And that kind of is like a threat modeling problem, right? Just people understanding like what really matters. Is encryption really going to save us in this situation? When you look at a system, really, in any given scenario, how are you thinking about threat modeling? And is there a resource like, you have a gas company, you walk in, they say, what should we be worried about? Like, is there a resource for that? Is that your intuition? Where does someone start threat modeling one of these kind of networks?
Yeah, so great question. So I'll try to answer it in two parts. Threat modeling or attack tree kind of simulation really comes about with understanding the control systems and how it operates. The first thing that I would suggest getting or an organization to have is really visibility. If you can't look at the security of the network or generally the control system traffic, then we really have no idea what we're looking for. Now, what distinguishes the ICS network visibility that I think we should all have as a best practice in any industrial control system sector is not just looking at the Windows OT communications. I'm really talking about the control systems. When those HMIs talk to back and forth to the PLCs, looking at that to see if it's normal, that is critical at the lower level. But in general, I'll ask the questions about architecture, which we've already covered, but also we do rely on vendors, I think, more in ICS, and that's great and wonderful, but it also means that we're open to more risk in ICS from an external party, if you will. I'm not talking cloud service here, but I'm talking vendors who we rely on to maintain and monitor some of our systems as well. And they can come to our sites to do maintenance, upgrade firmware of solid state PLCs and so on. So the question I ask beyond architecture is, how do you manage in oil and gas, in electric, in wastewater management? How do you manage the transient device risk? How do you monitor and manage an organization having contractors or integrators welcome to the site, but come on site with assets that they have, that they manage, that may have been in a hotel network the night before kind of thing, right, on their travels? How do you manage their assets that come into the plant and possibly introduce a risk? Because those devices, John, they're under someone's arm. They come into the plant. They walk by all of your physical security. They walk by your firewalls. They get red access to the plant floor, and they plug into a critical asset, which is a PLC, an RTU, and a meter in the plant. So I'd ask that question: how do you manage transient devices? That's where I'd start.
That's an interesting one because I've seen that exactly happen. I used to work at a company with a lot of these kind of systems, and it was years ago, but I distinctly remember a configure walking in on a USB drive and getting put into a manufacturing network one day. I'd be like,
yeah.
It's a tough problem to solve sometimes.
You raised a really good question. I mean, you mentioned configure there, and the times that we've responded or I've responded to incident response at an OT plant, and we go in, it's like the SCADA system is bogged down. It's like, it's not the next Stuxnet, it's not Trisis version 2 or crash override, but it's IT malware that also can impact the industrial control system, possibly brought in through a transient device. Now, you raised a really good point about, and I get this all the time when I'm presenting to boards of directors. It's like, okay, thanks for the briefing. We've heard about Trisis, we've heard about crash override, black energy, and so on. But that's like, and even Ekans ransomware, Snake ransomware. Like, we've heard about those 5 to 6 top families of ICS tailored malware. So why should I care about ICS security? Because, IT security tells me there's like thousands and millions every day or every year. And I really kind of have that conversation of, well, you do have traditional Windows devices that can be impacted. So it's not just the next crisis we're looking for to prevent happening in the ICS and detect and respond to. Even IT malware can have some impacts in the industrial control systems to a degree as well. And I'm not saying the next ransomware is going to turn the lights off to a region. That's not the case. There's a nuanced discussion there. But it's really the case of, back to the earlier discussion of, we've adapted and adopted IT-related technologies for the last 20 years. We've converged, which means now we have ICS-specific actors targeting us, but also some of the IT contaminants can also have impacts as well.
Mm-hmm. So let's get a little technical on solutions here. If we have to watch for all of this stuff, and we also have to segment it, a lot of times that means air gaps and other things like that. How do we safely get data from all of these systems back out to a SOC or whoever's doing the analysis without potentially letting people back in with, malware and everything else?
Yeah, so great question. I'll try to answer that in two different parts. So with regards to visibility, the biggest thing here, and it again highlights a difference between IT and ICS, is that the ICS IDS, if you will, intrusion detection system inside the industrial control environment, really needs to understand industrial protocols. So beyond just Modbus TCP and Profinet, for example, Ethernet IP and SIP and HARP protocol, like there's a whole slew of specific ICS protocols that are out there. And we've just recently released cheat sheets actually that kind of walks folks down through what those protocols are and how to look for them. So generally what I'm suggesting is the network security monitoring or intrusion detection technology for ICS really has to have dissectors to understand, dissect, and look at these protocols. Some of them are proprietary, but there is a ton of support out there for common tools now that we can deploy inside the ICS. So Suricata, for example, Snort, Zeek, there's a slew of them which have ICS components, even Wireshark as well. So even using those basic tools, any team looking at ICS security from a technical perspective can do a lot of good defense without spending too much in the first year of maturity. Definitely a place to start would be there. Now, the second thing is really about where in the network can we get this technology that understand the protocols. And of course, it's really important to have that segmented network first, but it's important to have the visibility in the network between the ICS and the IT, what's going in and out, that northwest kind of traffic. But more importantly now than ever, because we are seeing abusing protocols at the lower level of the ICS, we need that east-west traffic and really the visibility from lower levels of Purdue, like level 1, level 2, and 3, being monitored by an intrusion detection system. And I say intrusion detection system because in IT, we're very familiar with intrusion prevention system. But in IT, we're okay with dropping some packets and having some false positives. In ICS, again, that's not where we want to be. So we prioritize intrusion detection systems for sure.
Is there any kind of like specific architecture you use, data diodes or whatever? Like, how do you make sure traffic, like logging traffic, only goes in one direction?
Yeah, great question. So there are data diodes out there, and those data diodes are apparently hardened. So from a hardware perspective, they only allow data to flow in one direction, which is outbound outside the ICS and not so much in. I've absolutely seen those in use, and they work depending on the architecture. I see more organizations not use them and just use traditional firewalls, segment out different zones. From a technical perspective, using hardware firewalls rather than VLANs as an example, which is a huge jump forward. With a traditional firewall segmenting out different zones, you not only have the ability to not just rely on VLAN security, if that is security, you have other places to do more monitoring as well, and other ways to do containment on a firewall or a certain zone when you have an incident in ICS. Now, you mentioned earlier about having the security event logs going somewhere for a central SIEM or a security team to look at all of these events. And I'm really happy and excited to say that even lower level devices, PLCs, even RTUs, now have the ability in many cases to do syslog. So we didn't before, and now we can get not just local logs on a box. We have to go visit a site that could be 4 hours into the woods, electric dam as an example. We can get these devices to give us on the network their information to look at it from a security perspective. So the question always comes up, where do you put these logs and who looks at the security events? And I've really seen organizations do a number of different things in this area. I've seen OT take on OT specific security and an OT specific SIEM. And that works very well. And that's awesome. Usually they have engineering folks, security folks in OT looking at that, understanding what that PCAP sniff test I talked about earlier, and then they know what's evil and what's not. That's the general easy version to look at it. I've also seen organizations combine a organizational OT/IT SIEM as well. And the great news about that is that it actually has what we like to call the ICS cyber kill chain stage 1 and stage 2 visibility. If we can understand that the IT network can be compromised possibly as a stage 1 impact, we have then visibility. The organization has visibility over events coming from IT and ICS. That's for sure the best way to get visibility. The key I see there and how I see organizations fail there but can win here is if the organization looking at that data, and it sounds simple, John, but the organization and the folks looking at that data needs to have that engineering knowledge, needs to have the differences in their head and the knowledge training behind them to understand, is this really a threat for ICS or is it just for IT? Or, are they coming at a stage 1 in IT and pivoting to ICS? Like, these are the kind of things that we really kind of try to put forth. So that's 2 different ways I've seen a SIEM inside of a control system environment or a facility. Yeah.
What about when things do go wrong, right? You mentioned IR and kind of prep for that earlier.
Yep.
In a complex scenario like this, it may be hard to predict what might happen, although hopefully threat modeling, you've kind of walked through some of those ideas. In SOX, we always talk about let's tabletop out these various scenarios and predict what red teamers are going to do. And, there's certain ways we can do that in that kind of environment. But in OT and ICS, is it the same approach? Is there a different approach? Like, how do we do the fire drill of this sort of thing so that we're not like, oh, totally new thing that we weren't anticipating came our way and now we have no idea how to address this?
Right. Yeah. So I think the approach is generally the same, but executing it is very different, like similar to the technologies. I love doing instant response tabletops for ICS and because there is so much value in it. The other thing with regards to tabletops and ICS, though, and I'll get to the technical instant response in a second, is that at the table, sitting down, talking through a tabletop in ICS, you don't just have the security folks. You have the engineering staff. You have the physical security staff. You have the safety team there as well. Because remember, an incident in ICS, whether it's cyber or not, it's a safety impact potentially to a plant, to people. So having the round table is bigger, and the teams at the table are much bigger. And they come from all over the organization. So I've done a lot of tabletops, and most recently was in oil and gas. And we kind of modeled it after the event that we seen with Colonial last year. And it was really great because we had the plant there, the engineers were there, but we didn't talk about security as much. It was really cyber safety, right? To leverage that physical security aspect or physical safety culture. So tabletops work very, very well. And the approach would be the same, but with different teams, but different impacts. So if in IT you have a ransomware impact and that's your tabletop scenario, then you're going to be wanting to see what visibility you have on IT, what systems can be compromised. If it is, how do you recover? How do you contain and all those things? But in ICS, ransomware does not mean that the lights are going out. You can still run in the industrial control systems in many cases from embedded human-machine interfaces. So in many organizations, you don't have to have a Windows OT device to continue to manage the plant. And we see some of that kind of come out in the conversations with these ICS tabletops. And so we've actually produced recently a kind of a cheat sheet and a blog on incident response tabletop specifically for ICS, where we say, here's 5 top ICS tabletops that are out there. And we threw in a bonus one as well, made it 6. And we really took these specific ICS tabletops from threat intelligence. What have we seen the adversaries in ICS do the last 2, 3, 4, 5 years, and modeled these suggestions based off of that? And we've really found that organizations are getting a lot of value out of using those top 5 or 6 if they have nothing in place today or a scenario for their plant. So they're adaptable to many sectors in ICS.
Very cool. Yeah, we'll make sure we get those in the show notes too for everyone listening and wondering what those might be. A different thing you touched on earlier as well was patching. And, that's kind of a whole different conversation, but in a system that is, somewhat segmented from everything else, and we're probably not vulnerability scanning it in the same way. Like, how do we keep track of where there are vulnerabilities and what's the strategy for addressing those in this kind of environment?
Yeah, so actually, we just released an ICS Defense Force episode where we talked specifically about this. It's like a 15-minute episode, which would go into detail. But to summarize that and just to add a bit more, patching for sure is different in ICS. Every 30 days in IT. In ICS, it might be every quarter, but it also might be every quarter on the Windows devices. Typically, we see that the vulnerabilities that we discover in ICS are not always actively scanning for vulnerabilities. There is some areas in the upper level of Purdue, for example, level 4, 3, where we can do some active scanning, which is further tested. But generally, it's passive scanning, understanding from passively looking at the traffic, what devices are there, and really understanding what the risks are and the threats against them. This obviously, of course, leads us to ICS-specific threat intelligence. So going beyond just IT threat intelligence, knowing what the adversary does for ICS is critical to understanding what's happening in the ICS. So even the MITRE ATT&CK framework has the ICS version of that, and we are seeing organizations pick up and subscribe to ICS-specific threat intelligence. So that can contribute to understanding what the vulnerabilities are. With regards to patching, in the electric sector, we are driven and motivated to patch more often than not 30 days, but more often than not in ICS, because NERC comes out and says every 35 days you need to assess what patches you need, and then 35 days after that you have to have a plan to mitigate, patch, and so on. So it's not necessarily every quarter we're patching. It could be driven by compliance requirements to do that more frequently. But in general, to answer your question, we are seeing organizations, security team, and engineers sit together to say, you know what, we're going to patch. And maybe it's not just from a security perspective. Engineers want to patch too, to get rid of bugs or have new features. So that can also drive patching. So I see ICS patching being much less frequent and aligned 100% with regards to engineering maintenance windows. So it's not a security patch window. It's like, oh, well, they're taking the generator offline in 2 months when it's not winter anymore in the electric sector. And we're okay to do that because it's less risk in spring if we have less capacity and electricity to be produced. So during that time, we're going to take the generator down when we don't have to produce as much electricity. And during that time, we can take systems offline, and that's when we security patch. So I really see it aligned to the engineering aspect for sure.
Very cool. The other thing I kind of wanted to ask was, when I think about the traditional, I guess, pen test, red team, or actual compromise type incident, like you can say there's a pretty common pattern, right? Like attackers fish their way in, they exploit someone, they gain privilege, they move around, they do that, and you can look for certain things. Is there like a prototype of when you see an ICS related compromise? Is there like a general story that you see over and over happen, or like what are the trends in attacks that you see?
Yeah, so I mean, like I've seen penetration testers come in and organizations say, we want you to do a pen test in ICS. And it's all the question then, John, about how far are you willing to let the penetration tester go? And like penetration testers are awesome. Don't get me wrong. Everybody's lovely and awesome. We're all working well together. But when I see a pen testing solution touching and changing lower level devices in engineering, I always question, why are we doing that? For an adversary to get to that point, they're already past the HMI, so the adversary can just use the HMI to cause havoc rather than create malware that costs them time and money and try to execute and test it at the lower levels. There's definitely benefit in penetration testing, but generally I see penetration testing from an IT perspective. How can an adversary get into the ICS from IT? And when the adversary gets there, can they get into the HMI? Can they take advantage of the OT-specific Active Directory? Can they grab cache passwords and then pivot laterally in the ICS? And generally, I see penetration testing stop there at the upper levels, probably level 3 in the ICS environment. Organizations that do go lower, totally cool. There's ways to do that. Obviously, testing is first and foremost. But again, I would suggest caution, because even with IT traditional security tools, you can get kicked out of the plant if something goes sideways. And we have to remember that anytime we do a penetration test, we're changing systems. And is it responsible? Everybody's going to make their own decision on this. Is it responsible to actively change the system when there is no threat, right? That could cause a safety impact. So there's a way to do it, and I don't know that here's a template, but I usually see it from how does an adversary get from IT to ICS through the data historian, or maybe there's an Active Directory that's shared between IT and ICS, which we don't recommend. Even with something like Mimikatz that's used on IT, CAS credentials are being grabbed there, and we see adversaries specifically try to pivot to ICS because of those CAS credentials and perhaps the same users' accounts. Having a trusted relationship between AD is not something we recommend.
Yeah, I guess that kind of leads to another question which is, you mentioned the Colonial Pipeline thing. You probably, heard about the Florida water plant situation. Mm-hmm. And for the listeners out there, basically, like, both of these attacks were like someone found their way into an IT system and then used that to, control and either take down or affect, ICS equipment. In the incidents that you've seen that were successful, is it more typically someone just like infecting an IT system and therefore ICS just can't operate safely, but they didn't actually infect the ICS network? Or do you more commonly see people like actually get in and like dropping ICS specific malware, playing with protocols at that level? What's more common?
Yeah, that's a great question. So what is more common, I think, in 30 seconds or less would be IT malware can definitely have an impact on ICS Windows devices. We don't traditionally see IT malware causing an impact at lower levels, which means you can likely still operate at a basic level, a control system. You can still maintain safety and reliability of operations. I think in the case with Colonial, the IT malware that was there, which was dark-side ransomware, that was impacting IT. I think out of abundance of caution, they did shut off the connectivity between IT and ICS and ultimately just shut the plant down in a safe way to make sure contaminant could not get over there and have some impact whatsoever. But I do want to point out there, in general, we are seeing adversaries that get into ICS that have purpose for ICS attacks, more so create tailored malware for ICS, but moreover, live off the land. If there's PowerShell in a box in ICS, they're using that just like they would in IT. But also the human-machine interface. They can pretend to be that operator to say, hey, I'm the power utility, click, let's turn the power off to an area. Let's open the control system and the breakers in the field at a substation to de-energize a location. So I think that ICS-specific targeted attacks definitely have done their homework. The good news is when we see a specific ICS attack, the adversaries are definitely in the environment far longer than we expect, which gives us as defenders a larger window to do detection, which goes us right back to having ICS-specific aware intrusion detection systems or ICS visibility. That's super, super critical.
Awesome. So yeah, it sounds like kind of covering from both angles, as I expected would be the answer to that. Is depending on what they're looking for and depending on what kind of systems you're operating. Yeah, could happen either way.
Yeah, and you mentioned the Oldsmar event, so the water utility, which was compromised from the internet. So it goes without saying, following the architecture, but two-factor authentication and so on and so forth, and all that kind of comes at play with any remote access. But in the case of Oldsmar, what we can do, organizations don't have to spend a ton of money to start understanding what the adversary already knows. And you know what I'm going to say, which is OSINT. And you can do specific OSINT for ICS and be ahead of the adversary and know what they already know. So again, back to organizations wanting me to do an assessment to say, here's $1 million we want to spend on XYZ technology. And out of those 5 things they want to do, the first one I see is visibility. I'm like, that is critical. The next thing is I would suggest taking those other 2 or 3 things and just pushing them off a few months and focusing on ICS-specific open source intelligence gathering. And once you become the adversary, think like the adversary from an OSINT perspective, you can understand if you have your thermostat connected to the internet, right, and so on and so forth. And I think with the Oldsmar event, there was a device, the human-machine interface, directly connected to the internet that was accessible. And that's something we don't like to see. And again, this stuff is definitely defendable, right?
Mm-hmm. That was, I believe, if I read correctly, TeamViewer was what let them in?
Yeah, it was TeamViewer that let them in. And So we actually another resource, right? We developed a cheat sheet that produced and pushed out to the organization to the community to say, if you go to your ICS sites, here's some things you want to consider to get there and have a successful security meeting. And one of those things preparing to get to an ICS site is doing open source intelligence. And so we talk about some of the freely available tools that organizations can use to really open up the ICS OSINT game and prepare. So that resource is available as well. And I do see students from my ICS 515 class and even the 418 class. From the 418 class, it's the managers saying, thanks for the resource, and they have their team execute these things. From the ICS 515 perspective, the more technical course, they go and execute this kind of preparation guide as well before they get the site, which includes the OSINT. So
very cool. Yeah, we'll be sure to get those resources in the notes as well. So as we move towards wrapping up here, final question. If you look into the future over the next couple of years of ICS attacks, is there any kind of predictions you'd make or things that you think people are going to need to start focusing on that maybe we weren't focusing on as much before?
Yeah, absolutely. So there's no question that we're seeing more targeted attacks towards ICS. Obviously, ransomware is on the rise. We're seeing things like Snake ransomware or Ekans ransomware that has capabilities to target maybe some ICS software to kill that. So it's becoming more of a concern. There's no question there, more sophistication. The good news is because we're going down that road of more hostile kind of intent in general, we have the time is now, I guess, to do one of the top 2 or 3 things we talked about. Architecture for sure. It's affordable. It can be done. Build a strong foundation for ICS security, specific ICS security. And on top of that, of course, having network visibility. If I could say one thing that we need is more network security visibility that understands the protocols. And the next thing, of course, would be someone who looking at that traffic and really understanding the engineering aspect. Just like in IT, right? If you get a new technology and put it in, it's not set and forget. Today, we have to go above and beyond that to do active defense, which is really where the adversaries are pushing us. I think transient devices in the future will continue to be an issue. There are solutions out there for that, processes and solutions. And I think that we really need to watch what connectivity we have, because we're continuing to onboard connectivity from IT and from the internet. And there's benefits there from a business perspective, but we need to be very keen on that principle of least privilege there, connectivity in and out. And I know I'm repeating this last one, but it's really all about having someone looking at the data who understands the ICS. Back to that sniff test, right? Of here's 2 different packets. What would you do, right?
Yeah, that's awesome. Sounds like a perfect place to end it. You laid out a perfect map there: visibility, architecture, training for everyone. Sounds very similar to IT, but it's but you really have to know this separate special space in a lot of cases, and the unique challenges associated with that. So maybe that doesn't come as a surprise to people, but hopefully we can get them out some of these resources, and this is going to spur some thinking on that. So for people who want to dive more into this, follow you, read some more information, see any presentations, where can we find you online?
Yeah, so I'm on Twitter, so Dean Cybersec, and the same on LinkedIn. I also have a weekly, every Tuesday, it's an ICS, security briefing, which is a live stream called ICS Defense Force. And we talk about whatever's like the hot topic is, patching or architecture or passive defenses and transient devices, like whatever's out there. The discussion happens every Tuesday.
Fantastic. All right. Well, I think that wraps it up. Very interesting, fun discussion, Dean. Thank you for sharing your expertise with us and being on the Blueprint podcast.
Thanks for having me, John.